Here we are, chapter 5. Chapter 5. Chapter 5. There's a lot of vocab in this 5.1, chapter 5, so it'd be a good idea to highlight, but we will be practicing. So, monomial is a real number, a variable, or a product, and it's just one constant by itself. So, if it's just one term by itself, the degree of a monomial is one variable, is the exponent of the variable. So, we'll get into the degree. The polynomial itself is when we are adding a whole bunch of stuff together. This right here is a polynomial right there. So if I'm going to be looking at a polynomial function, that means that it is a function. This right here would give me my cubic term because my degree here is 3. So this right here would be the degree of the polynomial. It does not matter about anything behind it. Your highest degree is your degree of your polynomial. Right here, because of this 2, that would be a quadratic term, okay? This, because there is no number here, would be linear, and this is constant, meaning this will never change. This is going to be a -2 no matter what. So it'd be a good idea to highlight this. This is basically a chart that we can always reference back to. If we have a 0 degree, that's just a number all by itself. This right here, this 5 is a monomial because there's only one term. If we have a linear function, that means that our variable is just like to the first right here because there's 2 terms, that's binomial. Here, this would be a quadratic. This is a quadratic because this is x squared. My degree here is 2. This is a monomial because this is one term here. Here, this is cubic because my degree is 3, and there's 3 terms, so that's a trinomial. This is quartic because my degree is 4, and this would be a binomial. And this is quintic because my degree here is 5. Again, my degree is my highest exponent. It does not matter about what's behind it. It's about the highest exponent there. When you are classing polynomials, the first thing you want to do is combine like terms and write it in standard form. Standard form means your highest degree first. So if I look at this first one, there's nothing that I can combine there, but it's not in standard form. So this is my highest degree, so I'm going to write that out first. And then I have the x and then the number. Now I can label this. This right here is quadratic because my degree here is 2, and there is 3 terms there, so it'd be a trinomial. Here, I'm going to first combine my like terms. I'm looking at my highest degree first. Here's my x to the 4th, so I'm going to have my x to the 4th out front. Then I look to see if there are any x to the 3rd. There isn't, but here I have an x squared and an x squared, so I have to combine those like terms first. -6 plus 10 would give me a positive 4x squared, so I combined those. I only have 1x, 4x, and I have a -12. So my degree here is quartic, because my degree here is 4. And there are 4 terms here. And anything that's 4 or higher would be a polynomial. I'm going to do poly of 4 terms. Besides that, if it's by itself, it's monomial. If there's 2 terms, it's binomial. If there's 3, it's tri. Anything above that is just you label number terms. I want you to try C and D by yourself right now. So the first one should look like this. That's in standard form. That's quartic because my degree here is 4 and there's 3 terms, so it's trinomial. Here this is quintic because of my degree here is 5 and 3 terms, trinomial. So now we talk about turning points in end behavior. For every polynomial, these are the 3 different end behavior. When I talk about end behavior, is where is the arrow going? There's usually stuff going on here at the middle by the origin, and then the arrows point someplace. So when we talk about end behavior, it's to infinity, negative infinity, to positive infinity. What's going on here? Turning points are when we're going to have a maximum or a minimum in the degree. So these are the examples of up, up, down, 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 up, and up, down. It's important to try to remember these two because this will be determined on if it's going to be the same or different direction. If they're going to be pointing the same direction, this means it's going to have an even degree. So like this has an even degree, this one had an even degree, even, odd. If we have an odd degree, they're going in opposite directions. Even, same, odd, opposite. Now, you can use this chart right here. If it's even, it's either going to be up, up, or down, down. This is where it's good if you remember that typically a quartic or a quadratic, we draw that U. If the negative was in front, that means it was pointing down, down. Odd is opposite. So a typical, if its number in front is positive, this is what it would look like. It's going down on the left and up on the right. Why would that be? It's because if we had something, let's say x cubed, because that's odd, if I plugged in -1 cubed, that would give me a -1. So that's why these are all going down, and +1 cubed would still give me a positive, and that's going up. If this is -1 from, it flips the arrows. So it flops the arrows, and then it would go up, down. So we can always tell the end behavior without actually graphing it all. So first I want to look at my leading term. So right here, this is already in standard form. This right here is my leading term, my highest degree. So my degree here is 3, and my leading coefficient, that's right here, that 4 is my leading coefficient, and my leading coefficient is going to be positive. So if my degree here is 3, remember, typically it looks like this. And because it's positive, it's going to stay just like this. So it would be, my end behavior would be down, up. So your two questions you're asking for is, what's your degree? What's your leading coefficient? That will tell you where the end behavior is going. Here, my leading coefficient, my degree here is going to be a positive, or an even, so that means they're pointing the same direction. My leading coefficient is negative. So if my leading coefficient is negative, that's going to flip those arrows. So that would be down, down. Right now I want you to pause the video and try to do C by yourself. Your degree is 3, your leading coefficient is negative, so that where it flips the arrows. So instead of pointing down, the negative will now point it up, and instead of pointing up, the negative will also point it down. So we have turning points when we're switching direction. So when you're talking about turning points, you can have at most 1 below the degree. So here my degree is 1. So there's 0 turning points here. If you notice, there's 0 turning points. Here my degree is 2. So my 1 turning point, meaning that I'm going this direction and then I turn my direction. When you have a degree of 3, just because you have a degree of 3 doesn't mean you have 2 turning points. That means you could have up to 2 turning points. So like here, if I'm going in this direction, here I turn my direction, here I turn. There's also a possibility when you're doing a cubic, this would be a cubic function, you might not have any turning points. So we're going to get into what graphing a cubic function is. The first thing I want you to do is get your graphing calculator out just like this, and I want you to go to y equals and plot in this graph. So I chose to do 0.5 cubed. If you're not sure what the cube is, put your little top hat right here, and then you can put the cube in. So I'm going to go to my table. So I'm going to go second graph to get to my table to look to see what points I can plot. It looks like I can plot -2, 4. So I go left 2, down 4. I can plot 0, 0. I can plot 2, 4. Looks like everything else is off the graph. Now, it might be helpful. This is not a straight line, so it might be helpful actually to also plot at -1, I'm going down 0.5, and at 1, I'm going up 0.5. Because there should be a curve to this. There should be kind of a curve. So I'm going to start below, and you should always draw it to the right. So I'm going to start below and try to go through each point. So notice how I'm kind of curving to make sure that I can fit each point. Now my end behavior is down, up, because this is an odd degree, and this is even. So I want you to try to graph the next one by yourself. I would rewrite this. So this should be kind of a hint. This negative on front should be a hint of what your end behavior would look like. I want you to try to graph that by yourself. So these are all the points I got from my handy dandy calculator. Now one thing I'm going to do is I'm going to look at my end behavior. So because it's kind of hard to see what's going on here. My end behavior, this degree is odd. That means it's going to be opposite. But because it's negative, that means my end behavior, those would flip. So it go up to down. So I'm going to actually first show you the graph. You can always go to the graph to kind of help you. But when I'm graphing this, so there is a loop-de-loop, I make sure to start up. So here I'm going to start on the left-hand side. I'm going to start up, and I'm going to try to hit every point. So I'm up, down. Now we'll get into these minimum and maximums, how to actually clearly find those points. But for right now, you did a great job. Have a great, grand, wonderful day.